Hello everyone, welcome to the channel Amazing Civil Engineering Studies.
Hello friends, in this video we will study about
irrigation, types of irrigation, sources of irrigation, water, techniques of water distribution in irrigation. What is irrigation? Irrigation is defined as the science of artificially providing water to the land in accordance with the crop requirement throughout the crop period for the complete nourishment of the plant. Irrigation may be defined as the process of artificially supplying water to soil for raising crops. The engineering of controlling and harnessing the various natural sources of water, by construction of dam and reservoirs, canals, and headwork, and finally distributing the water to the agriculture fields is called as irrigation engineering. Irrigation is defined as the process of artificial application of water to the soil for the growth of agricultural crop. Basically a planning and designing a water supply system for agricultural land to protect the crops from bad effect of drought or heavy rainfall. Irrigation basically means artificial application of water to the fields. Water needed by different crops varies in amount and also at different stages of growth, water requirement is different. So, we need to apply water artificially to the field to meet the water demands of crop for proper growth. Necessity of irrigation in India. India is basically an agricultural country, and all its resources depend on the agriculture output. Water is evidently the most vital elements in the plant's life. Water is normally supplied to the plants by nature through rains. However, the total rainfall in a particular area may be either insufficient, or ill-timed. In order to get maximum yield, it is essential to supply the optimum quantity of water, and to maintain correct timing of water. This is possible only through a systematic irrigation system by collecting water during the period of excess rainfall and releasing it to the crop as and when it is needed. Thus the necessity of irrigation depends upon following points. A. Less rainfall. B. Non-uniform rainfall. C. Growing a number of crops during a year. D. Growing perennial crops. E. Commercial crops with additional water. F. Controlled water supply. Water is necessary for plant growth and maturity. It is not always possible to get water from natural means. Irrigation, the artificial means of supplying water, becomes important for plant growth in the following cases. If rainfall is less than the demand for plants, irrigation is necessary to fulfill the water requirement of plants. The difference in water holding capacity of the soil plays an important role in the necessity of irrigation supply. For example, sandy soil requires frequent irrigation than clay soil. If rainfall is sufficient but spatial distribution is not as per requirement, irrigation becomes necessary. If rainfall is sufficient, spatial distribution is also good but temporal distribution is not as per requirement, irrigation water is necessary for plants. An advanced scientific development like high-yielding varieties seeds, HYV, demands irrigation. Actually, irrigation is the most important input for HYV. Rainfall versus irrigation method. Rainfall is nature's irrigation process, but it does its work through precipitation, which is water falling from the sky to the soil. The quality of the food doesn't depend on the shortage of water but is open to water shortage when rainfall is less. Irrigation is the artificial process of pouring water all over the soil by various processes such as spraying, tubes, and pumps. Often on temperate zones and places where the rain falls once in a year or rarely needs this artificial process. There are many types of irrigation system that I would be including in the next paragraph. Irrigation water can come from various locations depends on the water link of that land. It can either come from wells/surface waters/rivers/lakes or groundwaters or other unnamed sources. Types of irrigation. The main types of irrigation are briefly explained in this video. Irrigation can be broadly divided into two main types, namely surface irrigation, subsurface irrigation. Surface irrigation is again divided into flow irrigation and lift irrigation. Subsurface irrigation system. Subsurface irrigation can be performed either naturally or artificially. Types of irrigation methods. Let me list some of the irrigation methods and how to use them. Irrigation method. Surface irrigation. Flooding. Wild flooding. Controlled flooding. Free flooding. Contralateral flooding. Border strip flooding. Check basin flooding. Basin flooding. Zigzag method of flooding. Furrow method. Contour farming. Subsurface irrigation. Sprinkler irrigation. Surface irrigation. Surface irrigation is again divided into flow irrigation and lift irrigation. Flow irrigation. In this type of irrigation, the water available at higher levels is allowed to move to the crops present in the lower level by the action of gravity. Flow irrigation is again classified into perennial irrigation, flood irrigation. Perennial irrigation. This irrigation system guarantees continuous and constant water supply to the crops throughout the crop period as per the requirement of the crop. This system supply water to the crops through a canal distribution system that takes off from a weir or a reservoir. If the irrigation water is taken by diverting the river runoff to the main canal by the construction of a diversion weir, then this irrigation is called as direct irrigation. If a dam is constructed across the river and the stored water is used to perform irrigation, then it is called storage irrigation. Direct irrigation is the simplest and most economical perennial irrigation. The perennial irrigation is also called as controlled irrigation. Application of surface irrigation. The surface irrigation system is a low-pressure irrigation system. Though it is a high-efficiency irrigation system, it is not flexible like subsurface irrigation system. Water is supplied over the soil. Water application is highly uniform and efficient. Water moves around the tube and moves out in all direction. Water is directly supplied to the soil surface. There are some factors which must be taken care of when applying surface irrigation. High-value strong-rooted vegetable crops like strawberry, tomato, potato, onions, and other vegetables grow well in the surface irrigation system. Melon crops are best grown. Depending on the soil type, you should use a variety of drip tubes. Water flow is dependent on how muddy or sandy your soil type is. The thickness of drip tubes is responsible for controlling water. A typical layout is always needed. It includes setting a pond, pumping unit, pressure relief valve, check valve, a sand media filter. In surface irrigation system, it is must to have a filtration unit. Filter all those nanoparticles so that they do not make your water filthy. This unit is actually clogged emitter. A filtration system is actually a sand media filter. In this irrigation process, sand media filter is highly desirable. Consideration different factors which are involved in the hydraulics of surface irrigation. Surface slope of the field. Roughness of the field surface. Depth of water to be applied. Length of run and time required. Size and shape of water course. Discharge of the water course. Field resistance to erosion. If the surface irrigation method is perfectly selected, it fulfills following requirements. It assists in storing required amount of water in the root zone depth. It reduces the wastage of irrigation water from the field in the form of runoff water. It reduces the soil erosion to minimum. It helps applying uniform application of water to the fields. Amount of manual labor required is less. It is suitable to the size of the field and at the same time it uses minimum land for making ditches, furrows, strips, etc. It does not avert use of machinery for land preparation, cultivation, harvesting. Advantages of surface irrigation methods. Surface irrigation offers a number of important advantages at both the farm and project level. The gravity flow system is a highly flexible, relatively easily managed method of irrigation. Because it is so widely utilized, local irrigators generally have at least minimal understanding of how to operate and maintain the system. In addition, surface systems are often more acceptable to agriculturalists who appreciate the effects of water shortage on crop yields since it appears easier to apply the depths required to refill the root zone. The second advantage of surface irrigation is that these systems can be developed at the farm level with minimal capital investment. The control and regulation structures are simple, durable, and easily constructed with inexpensive and readily available materials like wood, concrete, brick and mortar, etc. For this purpose canal lining from PCC, RCC, and bricks are done. Further, the essential structural elements are located at the edges of the fields which facilitates operation and maintenance activities. Energy requirements for surface irrigation systems come from gravity. This is a significant advantage in today's economy using negligible energy means. They are less affected by climatic and water quality characteristics. For instance, sediments and other debris reduce the effectiveness of trickle systems and wind affects the sprinkler systems. Salinity is less of a problem under surface irrigation than either of these pressurized systems. Surface systems are better able to utilize water supplies that are available less frequently, more uncertain, and more variable in rate and duration. Disadvantages of surface irrigation methods. There is one disadvantage of surface irrigation that confronts every designer and irrigator. The soil which must be used to convey the water over the field has properties that are highly varied both spatially and temporally. They become almost undefinable. This creates an engineering problem, in which at least two of the primary design variables, discharge and time of application, must be estimated. This estimation should not only be done at the field layout stage but also judged by the irrigator prior to the initiation of every surface irrigation event. Thus, while it is possible for the new generation of surface irrigation methods to be attractive alternatives to sprinkler and trickle systems, their associated design and management practices are much more difficult to define and implement. Surface irrigation technique is broadly classified as basin irrigation. Different types of surface irrigation systems used are: basin irrigation, furrow irrigation, border irrigation, basin irrigation. Irrigation of land by surrounding it with embankments to form a basin and flooding it with water. Basin irrigation is one of the oldest methods of irrigating and is widely practiced where rice is irrigated. Suitable crops. Basin irrigation is suitable for many field crops. Paddy rice grows best when its roots are submerged in water, and so basin irrigation is the best method to use for this crop pastures. E.g. alfalfa, clover, trees, e.g. citrus, banana, crops which are broadcast, such as cereals. To some extent row crops such as tobacco. Suitable land slopes. The flatter the land surface, the easier it is to construct basins. On flat land, only minor leveling may be required to obtain level basins. It is also possible to construct basins on sloping land, even when the slope is quite steep. Level basins can be constructed like the steps of a staircase, and these are called terraces. Suitable soils. Clays, loamy soils are preferred for basin irrigation so that waterlogging, permanent saturation of the soil, can be avoided. Coarse sands are not recommended for basin irrigation as, due to the high infiltration rate, percolation losses can be high. Also, soils which form a hard crust when dry, capping, are not suitable. Basins should be small if the slope of the land is steep, soil is sandy, stream size to the basin is small, required depth of the irrigation application is small. Field preparation is done by hand or animal traction. Basins can be large if the slope of the land is gentle or flat. Soil is clay. Stream size to the basin is large. Required depth of the irrigation application is large. Field preparation is mechanized. Irrigating basins. The direct method irrigation water is led directly from the field channel into the basin through siphons, spiles, or bund breaks. The cascade method on sloping land, where terraces are used, the irrigation water is supplied to the highest terrace, and then allowed to flow to a lower terrace and so on. Maintenance of basins. Bunds are susceptible to erosion, which may be caused by, for example, rainfall, flooding, or the passing of people when used as footpaths. Rats may dig holes in the sides of the bunds. It is therefore important to check the bunds regularly, notice defects and repair them instantly before greater damage is done. Before each growing season, the basins should be checked to see that they remain level. During pre-irrigation, it can easily be seen where higher and lower spots are. There should be smoothed out. Also, the field channels should be kept free from weeds and silt deposits. Furrow irrigation. Furrow irrigation is a method of laying out the water channels in such a way where gravity plays the role of providing just enough water for suitable plants to grow. It is usually made by the planned placement of ridges and furrows. It is a kind of surface irrigation system. In modern farming, chemical products are used like superabsorbent. Advantages to furrow irrigation include a lower initial investment of equipment and lower pumping costs per acre-inch of water pumped. Disadvantages include greater labor costs and lower application efficiency compared to sprinklers and subsurface drip irrigation. The number of furrows irrigated acres in Nebraska has decreased from 2.4 million to approximately 1.5 million acres in the past 10 years. Furrow irrigation is a method of laying out the water channels in such a way where gravity plays the role of providing just enough water for suitable plants to grow. It is usually made by the planned placement of ridges and furrows. It is a kind of surface irrigation system. A ridge is the part of the layout of the field that is elevated at different angles based on the type of soil. This is actually where the plants are planted. The furrows are the troughs which let the water flow through it. Why use furrow irrigation? Furrow irrigation is a more preferred way of irrigation primarily for two reasons. Cost reduction for irrigation. A more guaranteed higher yield. If these two factors are viable enough for your purpose, then furrow irrigation is more than just a good option for you. When to use furrow irrigation? In order to know whether the furrow irrigation method is suitable for your purpose or not, you need to have prior knowledge about some of the common factors of a field. After all, a little knowledge is a dangerous thing. Hence, to prevent such a phenomenon from happening, here are some of the main factors to be considered while using the furrow irrigation method are soil, plants, slopes. Soil. The key feature to keep in mind while selecting soils for furrow irrigation construction is the aggregating capacity of the soil. Simply put, the less soft it becomes in contact with water, the more suitable it is for furrow irrigation. This puts sandy soils as the least suitable since water regulation will be absent. Soil types like clay, loamy and silty soil are very much suitable for furrow irrigation. Plants. Noticing furrows in the backyard of a house in a patch of the vegetable garden is a very common sight. Thus, we can easily assume that furrow irrigation is very suitable for most crops and vegetables. It is very benefiting as a process when the roots need regulated contact with water, but contact with the stem or other parts would cause harm, hence the elevation. For example, growing row crops like wheat, maize, and paddy, some fruits and obviously most vegetables can use this method for proper results. Slopes. Sloping for furrow irrigation is not extremely done. Still, it does need to be adjusted slightly according to the type of soil present. The table below charts out the suggested angles for the slopes during furrow irrigation construction. Soil type. Optimum slope, %. Sand. 0.5 sandy loam. 0.4 loam. 0.3 silt loam. 0.2 clay loam. 0.1 clay. 0.05. Furrow planning. A lot of factors need to be kept in mind while implementing the furrow irrigation design. The crucial factors at play and important notes to keep in mind during the furrow planning design are: shape. There are two prime factors that you need to consider while creating the shape and size of the furrows. They are: soil type. If the soil is sandy, the furrows should be rather deep and narrow. This is because sandy soil has less impenetrability. On the other hand, if the soil is clay-like, then the furrows should be shallow and wide. The reason is more impenetrability and thus more presence of water in contact with soil for optimum wetting. Water stream flow. If the water flow is more, the furrows should be bigger and deeper in size for increased holding capacity of water. Length. Factors affecting the length of furrows are: slope. A maximum and minimum of 0.5 to 0.05% slope range of the soil will determine the length of the slope. The steeper a slope is, the longer a furrow can be. Soil type. The sandier a field is, the shorter the furrow will be. A vice versa situation applies to clay-like soil. Stream size. To avoid soil erosion, it is advised to keep the water flow not more than 3 liters SEC and not less than 0.5 liters section, subject to changes based on soil. Irrigation depth. The deeper a furrow, the more it can contain water and hence, the longer it can be. Cultivation practice. If you require cultivation frequently, try shorter furrows. Field length. The ideal size can be overlooked and can be adjusted to the length of the field. You may find this contradictory, but this is a choice between optimization of space and more yield rather than an ideal length where the prior is suggested. Space. For planning the space, you should keep these two factors in mind. Bed soil. This too depends on the soil type a lot. For coarse to fine sand to clay soil, the lesser penetrable the soil is, the lesser spacing respectively. This is due to differences in depth of furrows in the length section above. Cultivation procedure. Oftentimes, you will see a dissimilarity in between the furrowing tool and the space required for the plants from one row to another. Both these characteristics need to be brought in halfways to ensure proper reach of soil to the roots. Furrow application steps. For the application of the furrow irrigation construction design, you can follow these steps. Drawing the furrows. The furrows can be marked out with chalk before taking out a ridger and creating furrows. Poles too can be used to achieve more accuracy. Ridging. The furrows need to be created with a ridger as long as the chalked out areas are not drawn in straight lines. Equal distancing. The distance between two ridges should be at least 5 meters. For easier maintenance, you could use a 4-ridging drawbar. Importance of furrow irrigation. In a world where water is increasingly becoming scarce, furrow irrigations can become a very cheap and efficient solution. With techniques like alternate irrigation alongside the furrow irrigation designs, this system is bound to save up both water and erosion. For an economic country, this irrigation system seems very cost-effective and is proven to be more promising in yields. Therefore, followings are the importance of furrow irrigation. An economic and efficient solution to irrigation problems. Saves water. Prevent erosion. As an economic technique, it leads to the prosperity of agriculture-dependent countries. Advantages and disadvantages of furrow irrigation. Advantages of furrow irrigation. Followings are the major advantages of furrow irrigation. Mass area irrigation. Cost-efficient method. Time and labor-saving method. Optimum water distribution. Disadvantages of furrow irrigation. Followings are the major disadvantages of furrow irrigation. Initial labor cost is more. Not suitable for some crops. Mineral surfacing phenomenon. Hassle maintaining water flow. Followings are the major advantages of furrow irrigation. Mass area irrigation. Cost-efficient method. Time and labor-saving method. Optimum water distribution. Followings are the major disadvantages of furrow irrigation. The initial labor cost is more. Not suitable for some crops. Mineral surfacing phenomenon. Hassle maintaining water flow. Border irrigation. Borders are usually long, uniformly graded strips of land, separated by earth bunds. In contrast to basin irrigation, these bunds are not to contain the water for ponding but to guide it as it flows down the field. When to use border irrigation? Border irrigation is generally best suited to the larger mechanized farms as it is designed to produce long uninterrupted field lengths for ease of machine operations. Borders can be up to 800 m or more in length and 3 to 30 m wide depending on a variety of factors. It is less suited to small-scale farms involving hand labor or animal-powered cultivation methods. Suitable slopes. Border slopes should be uniform, with a minimum slope of 0.05% to provide adequate drainage and a maximum slope of 2% to limit problems of soil erosion. Suitable soils. Deep homogeneous loam or clay soils with medium infiltration rates are preferred. Heavy, clay soils can be difficult to irrigate with border irrigation because of the time needed to infiltrate sufficient water into the soil. Basin irrigation is preferable in such circumstances. Suitable crops. Close-growing crops such as pasture or alfalfa are preferred. Border layout. The dimensions and shape of borders are influenced in much the same way as basins and furrows by the soil type, stream size, slope, irrigation depth, and other factors such as farming practices and field or farm size. Many of the comments made about basins and furrows are generally applicable to borders also and so do not require repetition here. Table provides a guideline to determine maximum border dimensions. It must, however, be stressed that this table is for general guidance only, as the values are based on field experience and not on any scientific relationships. Suggested maximum border lengths and widths. Soil type. Border slope, %. Unit flow per meter width. L/SEC. Border width, m. Border length, m. Sand, 0.2 to 0.4. 10 to 15. 12 to 30. 60 to 90. Infiltration rate greater than 25 mm H. 0.4 to 0.6. 8 to 10. 9 to 12. 60 to 90. 0.6 to 1.0. 5 to 8. 6 to 9. 75. Loam, 0.2 to 0.4. 5 to 7. 12 to 30. 90 to 250. Infiltration rate of 10 to 25 mm H. 0.4 to 0.6. 4 to 6. 6 to 12. 90 to 180. 0.6 to 1.0. 2 to 4. 6. 90. Clay, 0.2 to 0.4. 3 to 4. 12 to 30. 180 to 300. Infiltration rate less than 10 mm H. 0.4 to 0.6. 2 to 3. 6 to 12. 90 to 180. 0.6 to 1.0. 1 to 2. 6. 90. Irrigating borders. Borders are irrigated by diverting a stream of water from the channel to the upper end of the border. The water flows down the slope. When the desired amount of water has been delivered to the border, the stream is turned off. This may occur before the water has reached the end of the border. There are no specific rules controlling this decision. However, if the flow is stopped too soon, there may not be enough water in the border to complete the irrigation at the far end. If it is left running for too long, then water may run off the end of the border and be lost in the drainage system. As a guideline, the inflow to the border can be stopped as follows. On clay soils, the inflow is stopped when the irrigation water covers 60% of the border. If, for example, the border is 100 m long, a stick is placed 60 m from the farm channel. When the waterfront reaches the stick, the inflow is stopped. On loamy soils, it is stopped when 70 to 80% of the border is covered with water. On sandy soils, the irrigation water must cover the entire border before the flow is stopped. Wetting patterns. As with the other irrigation methods, it is important to ensure that adequate irrigation water is supplied to the borders so that it fills the root zone uniformly. However, there are many common problems which result in poor water distribution. These include Poor land grading. Wrong stream size. Stopping the inflow at the wrong time. Poor land grading. If the land is not graded properly and there is a cross slope, the irrigation water will not spread evenly over the field. It will flow down the slope, always seeking the lowest side of the border, see figure. This can be corrected by regrading the border to eliminate the cross slope or by constructing guide bunds in the border to prevent the cross flow of water. Wrong stream size. A stream size which is too small will result in deep percolation losses near the field channel, see figure, especially on sandy soils. If the stream size is too large, the water will flow too quickly down the border and the point where the flow should be stopped is reached before sufficient water has been applied to fill the root zone, see figure. In this situation, the flow will need to be left running until the root zone has been adequately filled, and this results in considerable losses from surface runoff. Large stream sizes may also cause soil erosion. Inflow stopped at the wrong time. If the inflow is stopped too soon, the water may not even reach the end of the border. In contrast, if the flow is left running too long, water will run off the border at the downstream end and be lost in the drainage system. Maintenance of borders. Maintenance of borders consists of keeping the border free from weeds and uniformly sloping. Whatever damage occurs to the bunds must be repaired, and the field channel and drains are to be weeded regularly. By checking frequently and carrying out immediate repairs where necessary, further damage is prevented. Flood irrigation. Flood irrigation, also called inundation irrigation, is an irrigation method that intentionally creates a flooded land condition. This makes the soil completely saturated. After this, occasional natural rainfall is sufficient for the maturity of the crops. This irrigation method is best suitable for lands where there is a river nearby with a higher water level and a controlled flow of water to the land is not possible. So, the water is allowed to flow in surplus until a flooded condition is reached. Hence, this irrigation is an uncontrolled irrigation system. Subsurface irrigation system. In the case of the subsurface irrigation system, the soil surface is not made wet. Instead, the water sufficient for the crops is provided by means of underground water by the action of capillarity. Subsurface irrigation can be performed either naturally or artificially. Natural subsurface irrigation: there are possibilities of water leakage from the water channels or pipes. The water moves through the subsoil and may irrigate the crops nearby. This water leakage may also increase the water level of underground water, which also helps to nourish the crops. This way, when underground irrigation is achieved without artificial subsurface irrigation system. In the artificial sub-irrigation system, artificial water channels are provided in the underground and water is supplied to the crops under the action of capillarity. This irrigation type is very costly and employed for crops that provide high returns and profit. In certain areas, small ditches are made in different locations of the irrigation land, so that water from the ditches may percolate and nourish the crops, which also is a method of subsurface irrigation system. Sprinkler irrigation. In the sprinkler technique of irrigation, water is sprinkled into the air and allowed to fall on the ground surface just like rainfall. The spray is done by the flow of water under pressure through small orifices or nozzles. The pressure is generally obtained by pumping. In agriculture, almost all crops are suitable for sprinkler irrigation system except crops such as paddy and jute. The dry crops, vegetables, flowering crops, orchards, plantation crops like tea, coffee are all suitable and can be irrigated through sprinklers techniques of irrigation. Through proper selection of nozzle sizes, operating pressure, and sprinkler spacing, the amount of irrigation water required to refill the crop root zone can be applied almost uniform at the rate to suit the infiltration rate of soil. The sprinkler irrigation is categorized according to the functions which are mentioned as under. The main irrigation system. The supplementary irrigation system. The protective irrigation system. The sprinkler irrigation system is effective for irrigation on uneven lands and on shallow soils. It is also suitable to coarse sandy terrain where the percolation loss is more and where, as a consequence, the frequency of irrigation required is more. The sprinkler irrigation system is appropriate in rising and falling land where land shaping is expensive or technically not practicable. The elimination of fertile soil cover by land shaping is not advisable. Sprinkler irrigation system can also be espoused in hilly regions where plantation crops are grown. Historical facts signified that though sprinkler irrigation system is known since 1946, yet the farmers started adopting it in huge scale only since 1980s. It began in the hilly areas of Western Ghats in states of Kerala, Tamil Nadu, and Karnataka, and in the northeastern states mainly for plantation crops like coffee, tea, cardamom, rubber. Gradually it spreads to the water scarcity and light soil states of Rajasthan and Haryana in addition to the black soil area of Madhya Pradesh. Advantages and disadvantages of sprinkler irrigation. Advantages of sprinkler irrigation. Elimination of the channels for conveyance, therefore no conveyance loss. It is suitable to all types of soil apart from heavy clay. It is appropriate technique for irrigating crops where the plant population per unit area is very high. It is most suitable for oil seeds and other cereal and vegetable crops. It saves water. With this technique of irrigation, there is control of water application convenient for giving light and frequent irrigation and higher water application efficiency. Sprinkle irrigation increases in yield. There is a mobility of system. It may also be used for undulating area. It saves land as no bunds are required. This technique influences greater conducive microclimate. Areas located at a higher elevation than the source can be irrigated. In this technique there is a possibility of using soluble fertilizers and chemicals. In this method of irrigation there is less problem of clogging of sprinkler nozzles due to sediment-laden water. The overall cost of labor is generally reduced in this method of irrigation. Erosion of soil cover, which is common in surface irrigation, can be reduced. Disadvantages of sprinkler system. In this technique, initial cost of implementation is high. High and constant energy requirement for operation. Under high wind condition and high temperature, distribution and application efficiency is poor. Highly saline water causes leaf burning when temperature is higher than 95 F. When lands have been already leveled and developed for surface or other irrigation methods, sprinkler irrigation is not so economical. There is loss of water due to evaporation from the area during irrigation. Drip irrigation. What is drip irrigation? Drip irrigation is a type of micro-irrigation system that has the potential to save water and nutrients, allowing water to drip slowly to plant roots, from the ground or below the surface. The goal is to put water directly into the root area and minimize evaporation. Drip irrigation systems distribute water through a network of pipes, tubes, valves, and emitters. Depending on how well it is constructed, installed, maintained, and operated, a drip irrigation system can be more efficient than other methods, like surface or sprinkler. How does drip irrigation work? Water and nutrients are delivered across the field in tubes called drip lines, featuring smaller units known as drippers. Every dripper emits drops containing water and fertilizers, resulting in the uniform application of water and nutrients directly to the root zone of each plant, across an entire field. Types of drip irrigation system. Drip irrigation works most effectively, depending on how they are designed. There are some variations in drip irrigation. They need a different installation process, in addition to good maintenance service. Some types of drip irrigation are: emitter drip system, porous soaker hose system, micro misting sprinkler, watermatic drip system, emitter drip system. The emitter drip system is known to emit small drops of water in the soil. They are good for the bushy landscape. A major problem with this drip system is that the emitters are clogged quickly. During the winter, the emitter drip system is difficult to work with. It is best to avoid this system at that time. The best thing is that the hoses are evenly spaced. Therefore, your plants receive water evenly. Throughout the garden, you will always be satisfied with the water supply. Porous soaker hose system. The porous soaker hose system is used in hedges, rows of shrubs and flower beds. It is very easy to operate. This is made from recycled products, such as car tires. It has several holes. Porous soaker hose has great durability. Your entire body has holes and exudes water. Therefore, the roots are always hydrated, regardless of the climate. Micro misting sprinkler. The micro misting sprinkler was built for vineyards and orchards. You can also use it in backyards. This system is capable of providing equal water to all roots. The false mist helps the shallow roots to remain calm, even on sunny days. That is why the leaves always look fresh, even in gloomy or hot weather. Your plants will never be dehydrated if you use this drip irrigation system. Watermatic drip system. Among all drip irrigation systems, the watermatic drip system is the best. This helps to conserve water when, on the other hand, it minimizes evaporation. In this system, the micro spray heads are best used. This is very important for trees and flower beds. You can use this system where there is an insufficient amount of water supply and use of recycled water. Uses of drip irrigation. You can easily use drip irrigation on farms, commercial greenhouses, residential gardeners. It can also be used where water is scarce. Drip irrigation can be effective for crop roots and trees such as coconut and grapes, berries, citrus fruits, strawberries, sugar cane, cotton, corn, and tomatoes. For effective use, use the main line with a return converter, connect a controller to it. A filter can also be used. The filter will ensure that no extra particles enter the tube without water. Connect a pressure regulator to it to be able to control the water supply. A good drainage system provides moisture and nutrients to the plants along with the water. Water is the most important ingredient for plants. The equal distribution of water facilitates the growth of plants. The drip irrigation system ensures that all your plants obtain water equally. Make sure it is installed properly. Don't forget to use environmentally friendly materials. All of this will give you a good gardening experience. Advantages of drip irrigation. Save water. Drip irrigation is the system's ability to water plants efficiently, due to the controlled delivery of water directly to the soil. Drip irrigation systems consist of tubes through which water travels from the source to the drip emitters, also called micro-sprinklers. The drip irrigation pipe meanders through the landscape beds and soil cover areas, and water literally flows from the emitters to the root areas of the. It is really a mouth-watering way. Easy installation. The drip irrigation installation does not require excavation and rarely disrupts the integrity of a landscape bed during installation. The piping is woven throughout the area that requires irrigation. Therefore, drip irrigation systems can be moved and are not permanent, like conventional irrigation systems, involving spray heads, pop-up heads, etc. Water conservation. With drip irrigation, water is delivered directly to the soil surface, instead of being sprayed over an area. This direct application of water saves no drift. Drip irrigation can deliver 1 to 4 gallons of water per hour to a landscape bed, and there is no drift, which happens when the wind takes dispersed water from the irrigation system to areas that do not need water. Its sidewalks, walkways, and parking lots. Drift wastes water. Water bill savings. More efficient irrigation in the landscape saves money. Due to an inadequate supply of water, fertilizers and nutrients cannot reach the roots of all. The drip irrigation system helps to achieve effectively. If you want to achieve efficiency in the application of water, it is necessary to install the drip irrigation system. Field leveling is done by installing this type of irrigation system. When your field is leveled evenly, you can plant correctly. Whatever the field capacity, they need. The roots must be hydrated. Soil erosion and weed growth are reduced. Water distribution can be controlled. According to the need, water is produced for all roots. You no longer need a helping hand to water your plants. Therefore, drip irrigation also confirms the zero cost of labor. It is a low-cost process that can also be done with low water pressure. Other irrigation method. Center pivot irrigation. Water is scattered throughout the land by a machine of sprinkles that move on wheeled towers in 360 degrees pattern, or a circle that would move around the land and sprinkle water all over the soil, and it is really efficient and effective, and this procedure or system is well recommended in a lot of country. IES but mostly used in USA. Lateral move irrigation. Water is scattered throughout the land evenly through a series of pipes or water lines. They can either be controlled by hands, which could be less effective compared to a man-made machine for sprinkling water all over the land. The sprinkles move only a recommended distance on the field, and for the next land, reconnection of the water hose is required to cover the next distance. Compared to the other irrigation systems, lateral move irrigation system tends to be way cheaper but requires a lot of labor or manpower. Sources of irrigation water: groundwater and surface water. Surface water. It is found on the surface of the land. These include spring water, river water, lake water, etc. This can be supplied to the field by weir, check dam, by gravity, or by using pump. Check dam weir / system is used only when the source of water is from river, or spring water that starts from upstream. Where the slope of the source of water is greater than the slope of the field to be irrigated. Pumps are used where the source of water for the field is at downstream, at lower altitude. Here mostly centrifugal type pumps are used. Groundwater. Where these is shortage of surface water, groundwater is used for irrigation. This is supplied only by using pumps. Irrigation efficiency definition and its types. Definition: the ratio of the amount of water available, output, to the amount of water supplied, input, is known as irrigation efficiency. It is expressed in percentage. Types of irrigation efficiency. The following are the various types of irrigation efficiencies. A. Water conveyance efficiency, A to C. It is the ratio of the amount of water applied to the land to the amount of water supplied from the reservoir. It is obtained by the expression A to C equals WLWR times 100, where A to C equals water conveyance efficiency, WL equals amount of water applied to land, WR equals amount of water supplied from reservoir. B. Water application efficiency, A to A. It is the ratio of the water stored in root zone of plants to the water applied to the land. It is obtained by the expression A to A equals WZWL times 100, where A to A equals water application efficiency, WZ equals amount of water stored in root zone, WL equals amount of water applied to land. C. Water use efficiency, A to U. It is the ratio of the amount of water used to the amount of water applied. It is obtained by the expression A to U equals WL times 100, where A to U equals water use efficiency, W equals amount of water used, WL equals amount of water applied to land. D. Consumptive use efficiency, CU. It is the ration of the consumptive use of water to the amount of water depleted from the root zone. It is obtained by the expression CU equals CUWP times 100, where CU equals consumptive use efficiency, CU equals consumptive use of water, WP equals amount of water depleted from root zone. Techniques of water distribution in irrigation engineering. The irrigation water can be distributed efficiently to the farms in various ways like free flooding, check flooding, border flooding, basin flooding, furrow irrigation method, drip, and sprinkler irrigation method. The type of technique chosen for the irrigation land depends on the soil texture, land contour, type of crop that is cultivated and the slope of the land. The major techniques employed for distributing the irrigation water are explained briefly in this video. Free flooding irrigation, border flooding irrigation, check flooding, basin flooding, furrow irrigation method, sprinkler irrigation system, drip irrigation method, free flooding irrigation. The free flooding technique is performed by excavating ditches in the irrigation land. As shown in the figure, from the main supply ditch, water is collected in the subsidiary or lateral or contour ditches. These subsidiary ditches are excavated either along the contour or above or below the slope of the area. The water from the lateral ditches is allowed to flow freely without any sort of control, and hence it is also called wild flooding. The wild flooding technique is best suitable for crops or pastures that are cultivated closely. The contour ditches excavated in free flooding techniques are mostly spaced at a distance of 20 to 30 m. This merely depends on the type of soil, type of crop, soil texture, etc. It performs well when employed on a sloped land or an irregular land. This method is not preferred where checks, basins, border, or furrows are feasible. The initial cost of land preparation of free flooding is very less, but it demands high labor requirements and possesses less efficiency. Border flooding irrigation. Border flooding method involves dividing the irrigation land into several strips of width around 10 to 20 m and length of 100 to 400 m. Each strip is separated by a border or levees. The ridges constructed between the borders must have sufficient height to prevent overtopping during the irrigation. As shown in the figure, the water is allowed to flow from the supply ditch to each strip. So to prevent water to concentrate in one area, the surface must be leveled in the direction perpendicular to the flow of water. As the water flows through the strip, it infiltrates at the lower end. At this point, the supply is closed. High efficiency is gained when the strips are short and narrow. Check flooding. Check flooding is a method similar to flooding where the water is controlled by the surrounding check area that is formed by the construction of levees. These levees can be short or long, which are constructed along the contour. Most of the check area has a measure varying from 0.2 to 0.8 hectares. In check flooding, the water from the supply ditch is allowed to move to the check area and is held for a period until desirable infiltration takes place. Check flooding is suitable for both permeable and less permeable soil. If applied for permeable soils, the water is quickly spread to the soil. While in case of less permeable soil, the water is allowed to stay for longer period to ensure adequate penetration. Basin flooding. Basin flooding is a special type of check flooding as shown in Figure 4. Here, the subsidiary ditches receive water from the main supply ditch. Each subsidiary ditch is connected to a basin that occupies one or more trees. This method is especially followed for orchard trees. Furrow irrigation method. In this method, furrows are made between rows of plants. Furrows are narrow field ditches that carry water with a length of 400 meters and a depth of 8 to 30 centimeters. The spacing of crops decides the spacing of the furrows. These are employed for row crops. Furrows can be made in corrugations for land areas with irregular topography. Excessive length of furrows must be avoided because long furrows may result in high water on one end and less water on the other end. The water from the furrows is diverted to the row crops by means of plastic tube siphons or border takeout or spiles or lathe box. Sprinkler irrigation system. The sprinkler irrigation system is a farm water application that applies water in the form of spray. This spraying is performed by a series of pipes and pumps. It is akin to artificial rainfall and hence nourish the crops with the required amount of water. The method is very costly and involves great technicalities. For examples, debris and silts must not enter these pipe system as it will affect the smooth operation of the sprinkler. Debris results in the choking of the nozzles while silt results in huge wear in the impellers, bearings, and the nozzles. Drip irrigation method. The drip irrigation method is also called trickle irrigation. In this system, the water is applied directly to the roots by an arrangement made underground. This hence results in the prevention of loss of water due to evaporation and percolation. This is a modern irrigation water distribution technique employed in areas where there is a scarcity of water and the presence of salts in the available water. Major advantages and disadvantages of irrigation. Read this article to learn about the major advantages and disadvantages of irrigation. Advantages of irrigation. For proper nourishment of crops, certain amount of water is required. If rainfall is insufficient, there will be deficiency in fulfillment of water requirement. Irrigation tries to remove this deficiency caused due to inadequate rainfall. Thus, irrigation comes to rescue in dry years. Irrigation improves the yield of crops and makes people prosperous. The living standards of the people is thereby improved. Irrigation also adds to the wealth of the country in two ways. Firstly, as bumper crops are produced due to irrigation, it makes country self-sufficient in food requirements. Secondly, as the irrigation water is taxed when it is supplied to the cultivators, it adds to the revenue. When watering facility is provided to a barren land, the value of this land gets appreciated. Irrigation makes it possible to grow cash crops which give good returns to the cultivators than the ordinary crops they might have grown in absence of irrigation. Fruit gardens, sugarcane, potato, tobacco, etc., are the cash crops. Sometimes large irrigation channels can be used as a means of communication. The falls which come across the irrigation channels can be utilized for producing hydroelectric power. Domestic advantages should not be overlooked. Irrigation facilitates bathing, cattle watering, etc., and improves freshwater circulation. Irrigation improves the groundwater storage as water lost due to seepage adds to the groundwater storage. Along the banks of large irrigation channels, plantation can be successfully done, which not only helps introducing social forestry but also improves environmental status of the region. New irrigation works are started at the time of famines to provide employment to a large number of population. These works are called famine works or relief works. Disadvantages of irrigation. Excessive seepage and leakage of water forms marshes and ponds all along the channels. The marshes and the ponds in course of time become the colonies of the mosquito, which gives rise to addis's like malaria. Excessive seepage into the ground raises the water table, and this in turn completely saturates the crop root zone. It causes waterlogging of that area. It lowers the temperature and makes the locality damp due to the presence of irrigation water. Under irrigation canal system, valuable residential and industrial land is lost. Initial cost of irrigation project is very high, and thereby the cultivators have to pay more taxes in the form of levy. Irrigation works become obstacles in the way of free drainage of water during rainy season, and thus results in submerging standing crops and even villages. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.